Today we will cover section 611, solve systems of equations by substitution and elimination. Example 1. Solve the system of equations by using the substitution method. Solve by substitution. So the equations given to us are y equals negative 7x and y equals x plus 8. Since we know that y equals negative 7x, we can substitute in negative 7x for y in the other equation. Or since y equals x plus 8, we can substitute in x plus 8 for y in the other equation. Let's substitute in negative 7x for y in the bottom equation. So that's negative 7x equals x plus 8. Now let's solve for x. X is being added, so to get rid of it, you do the opposite and subtract x from each side. Negative 7x, or negative x is the same thing as negative 1x. Negative 7x minus 1x is negative 8x. X minus x is 0, so it cancels out. And then x is being multiplied by negative 8, so to get rid of negative 8, do the opposite and divide each side by negative 8. The negative 8's cancel out. A positive divided by negative is always negative, so x equals negative 1. Now we can substitute in negative 1 for x in either of the equations to solve for y. Let's substitute it in up here. So that's going to be y equals negative 7 times negative 1. It's good to use parentheses when substituting a number in for a variable. That preserves the multiplication going on between negative 7 and x. Negative 7 times negative 1 is positive 7, so y equals 7. If you want to write the answer in coordinate form, that would be parentheses, x number, negative 1, comma, the y number 7. And then to check the answer, substitute in negative 1 for x in both equations and substitute in 7 for y in both equations. And if it makes both equations true, you know you have the correct answer. Let's do that really quick. So that's going to be, for the top equation, 7 equals negative 7 times negative 1, which gives us 7 equals 7, which of course is true. Now substituting in to the bottom equation, y equals x plus 8, that's going to be 7 equals negative 1 plus 8. 8 to the right of negative 1 on a number line is 7, so we get 7 equals 7 again, which of course is true. So negative 1 and 7 worked for both equations, so it must be the correct answer. Now let's go to example 2. So again, we're going to solve by substitution. Let's write that down. And the system of equations given to us in this problem is y equals negative x over 5 and y equals x minus 6. So since y equals negative x over 5, we can substitute in negative x over 5 for y in the other equation. Or since y equals x minus 6, we can substitute in x minus 6 for y in the other equation. Let's substitute in negative x over 5 for y in the bottom equation. That gives us negative x over 5 equals x minus 6. And to get rid of that denominator so that we're not dealing with fractions, multiply both sides of the equation by the lowest common denominator, which is 5. So each term gets multiplied by 5, in other words. So negative x over 5 times 5 equals 5x minus 30. Each side got multiplied by 5. Okay, so the 5 on top cancels out with 5 on the bottom when multiplying. So we get negative x equals 5x minus 30. And then subtract 5x from each side. Because it's positive 5x, subtract 5x from each side to cancel out the 5x. Because that gives us 0, and 0 minus 30 is negative 30. Negative x is the same thing as negative 1x. Negative 1x minus 5x is negative 6x. Divide each side by negative 6, or you can just realize that x equals 5, because negative 6 times 5 equals negative 30. A negative times a positive is always negative. So x equals 5, and now to find y, substitute in 5 for x in any of the equations. Let's substitute it into this equation here. So that's going to be y equals 5 minus 6, which equals negative 1. If you want to write the answer in coordinate form, it's parentheses, x number, comma, the y number. So 5 comma negative 1. And then to check the answer, let's substitute in 5 for x in both equations and negative 1 for y in both equations, and see if we get true equations for both. If so, then we know that we have the correct answer. So for the top equation, that's going to be negative 1 equals negative 5 over 5, which is going to give us negative 5 divided by 5 is negative 1. So we have a true equation, negative 1 equals negative 1. Now let's see if it works for the bottom equation, substituting in negative 1 for y and 5 for x. That's going to be negative 1 equals 5 minus 6. 6 to the left of 5 on a number line is negative 1. So we get a true equation again. Negative 1 equals negative 1. So our solution, x equals 5, y equals negative 1, or 5 comma negative 1, must be correct. Now let's look at example 3. Example 3, solve by substitution again. Solve by substitution. We get 6x plus 3y equals 15. And the other equation given to us is 3x plus 3y equals 9. It would actually be easier to solve this by elimination, but let's get some practice with substitution first before I introduce elimination. Okay, so the tricky part here is all 4 variables here are being multiplied by a number. None of the variables are isolated. So let's isolate one of the variables before we can substitute in. We can isolate x in the top equation, or isolate y in the top equation, or isolate x in the bottom equation, or isolate y in the bottom equation. I would not recommend isolating x in the top equation because that's multiplied by 6, which is bigger than all the other numbers multiplying the other variables. Let's isolate x in the bottom equation. by subtracting 3y from each side. That gives us 3x equals 9 minus 3y. And then x is being multiplied by 3, so to get rid of the 3, do the opposite and divide each side by 3. So each term gets divided by 3. The 3's cancel out on the left. 9 divided by 3 is 3. Negative 3y divided by 3 is negative 1y. Since a negative divided by a positive is always negative. Now that we know that x equals 3 minus 1y, we can substitute in 3 minus 1y for x in the other equation. So in the top equation. So I'm going to move down here. That's going to be 6 times 3 minus 1y. You should use parentheses when substituting in for a variable. Because 6x means 6 times all of x, so it's 6 times all of what x is equal to, so you need the parentheses to indicate that. Then distribute the 6, multiply each term in the parentheses by 6. 6 times 3 is 18. 6 times negative 1y is negative 6y. Plus 3y equals 15. Add the like terms. Negative 6y plus 3y is negative 3y. Subtract 18 from each side. 18 minus 18 is 0, so it cancels out. Negative 3y equals 15 minus 18, which is negative 3. Divide each side by negative 3. The negative 3's cancel out. Negative 3 divided by negative 3 is positive 1. Now to find x, substitute in 1 for y in any of the equations, but this one would be the easiest equation since x is already isolated in that equation. That gives us x equals 3 minus 1 times 1 when we substitute in 1 for y. According to PEMDAS, we do m for multiplication before s for subtraction. 1 times 1 is 1, 3 minus 1 is 2, so x equals 2. And of course, you can check your answer by substituting in 1 for y and 2 for x in both equations, and if it makes both equations true, you know you have the correct answer. But we're not going to do that this time for the sake of time. Now let's go to example 4. And we're going to learn solving by elimination this time. Example 4. We're given 3x plus y equals 7. And the other equation in our system of equations is negative 3x plus y equals 13. Solve by elimination. Okay, so to solve by elimination, you either add the equations together to eliminate one of the variables or subtract the equations to eliminate one of the variables, depending on the situation. So first I'm going to show you why adding equations works. Let's say we have two random equations, such as, let's say 3 plus 4 equals 7 and 5 plus 8 equals 13. If I add those equations together, 3 plus 5 is 8, 4 plus 8 is 12, 7 plus 13 is 20. I get a true equation when I add the equations together. You always get a true equation whenever you add equations together. And the reason why is because since 5 plus 8 equals 13, when I added 5 plus 8 to the left side of the top equation and 13 to the right side of the top equation, I was really adding the same amount to both sides of the top equation, so the resulting equation is true. Now I'm going to show you why subtracting equations always results in a true equation. Let's take two random equations, such as let's say 12 plus 4 equals 16, and let's say 5 plus 3 equals 8. Now let's subtract the equations. 12 minus 5 is 7, 4 minus 3 is 1, 16 minus 8 is 8, 7 plus 1 equals 8, of course, is a true equation. So subtracting the equations works to get a true equation, because since 5 plus 3 equals 8, when I subtracted 5 plus 3 from the left side of the top equation and subtracted 8 from the right side of the top equation, I was really subtracting the same amount from both sides of the top equation, so the resulting equation is true. So anytime you subtract equations, it always results in a true equation. Now that you know that, let's solve this system of equations by elimination. So we actually have two options for this system, which doesn't normally happen. We can either add the equations together to eliminate the x terms, because 3x plus negative 3x plus negative together makes a minus. 3x and 3x minus 3x is 0. Or we can subtract the equations to eliminate y, because y minus y is 0. Let's first show you how to solve by adding the equations to eliminate x. So adding the equations, 3x plus negative 3x, like I said, plus negative together makes minus, so it's 3x minus 3x, which is 0, so it cancels out, x gets eliminated. And then y plus y is 2y, right? Y is the same thing as 1y, and 1y plus 1y is 2y. And 7 plus 13 is 20. Divide each side by 2, or just realize that y equals 10 because 2 times 10 is 20. And then to find x, substitute in 10 for y in either of the equations given to us in the problem. Let's substitute it into the top equation. That would be a little bit easier since all the terms are positive and the numbers are smaller. I'm going to get this out of the way. That's going to be 3x plus 10 equals 7. Subtract 10 from each side to get 3x equals a negative 3. Divide each side by 3. The 3's cancel out. Negative 3 divided by 3 is negative 1. So y equals 10 and x equals negative 1 is the solution. And you can check your answer by substituting in 10 for y in both equations and negative 1 for x in both equations. And if both equations end up being true as a result, then you know you have the correct solution. Now I'm going to show you how we could have solved it by subtracting the equations to eliminate y. So 3x plus y equals 7. Negative 3x plus y equals 13. So subtracting the equations, 3x minus negative 3x, the two negatives there make a positive, so it's 3x plus 3x, which is 6x. And then, so that negative applies to each term. Y minus y, right? Minus and plus together is just minus. So y minus y is 0. So y is eliminated. And then 7 minus 13 is negative 6. Because a smaller number minus a larger number is always a negative. Or 13 to the left of 7 on a number line is negative 6. And then divide each side by 6. Or you can realize that x equals negative 1 because 6 times negative 1 equals negative 6. A positive number times a negative number is always negative. And now to find y, substitute in negative 1 for x in either of the equations given to us in the problem. Let's use the bottom equation this time. Use parentheses when substituting in. That's negative 3 times negative 1 plus y equals 13. Negative 3 times negative 1 is positive 3. And then subtract 3 from each side, or just realize that y equals 10 because 3 plus 10 is 13. Notice we get the same answer as we did when we added the equations to eliminate x. Now let's look at example 5. And then we'll look at a word problem, and then we're done. Example 5, solve by elimination. This is one of the most important lessons in the entire book. This is foundational to algebra. It's used a lot in science, economics, business, solving a system of equations. Okay, example 5. We have y equals 1/5 x plus 2 and y equals negative 1/5 x minus 4. So I wanted to present a problem involving fractions so that you're prepared to solve the fraction problems in the homework. Okay, so again, we have two options. We can subtract the equations to eliminate y, or add the equations to eliminate x. Usually you're not going to have two options, but we do in this case. First, I'm going to show you how we can add the equations to eliminate x. Anytime you have the same exact terms in both equations, you can add the, anytime you have, let me say that again. Anytime you have the exact same terms in both equations except one's positive and the other's negative, you can add the equations to eliminate the variable. So adding the equations together, each term gets added. Y plus y is 2y. 1/5 x plus negative 1/5 x. Plus and negative together makes minus, and 1/5 x minus 1/5 x is 0, so it gets eliminated. And then 2 plus negative 4, again plus and negative together is minus. 2 minus 4 is negative 2. Divide each side by 2. The 2's cancel out. Negative 2 divided by 2 is negative 1, so y equals negative 1. And then to find x, substitute a negative 1 for y in either of the equations. Let's substitute it into the top equation. So that's negative 1 equals 1/5 x plus 2. Subtract 2 from each side. You have to wait until the end to get rid of a number that the variable you're solving for is being multiplied or divided by, so wait until the end to get rid of 1/5. That's why I'm subtracting 2 from each side first. Negative 1 minus 2 is negative 3, equals 1/5 x. 2 minus 2 is 0. To cancel out a fraction that's multiplying a variable, the shortcut is to multiply each side by the reciprocal of the variable, by the reciprocal of the fraction. In other words, the fraction flipped upside down. So 5 on top cancels out with 5 on the bottom, and 1 on top cancels out with 1 on the bottom when multiplying. And then 5 times negative 3 is negative 15. Dividing by 1 does not affect the value, so ignore that 1. X equals negative 15. And you can check your answer by substituting in negative 1 for y and negative 15 for x in both equations, and they would form true equations in each case, so that's how you can know that we have the correct solution. Now I'm going to show you how we can solve by subtracting the equations and eliminating y. So that's going to be y equals 1/5 x plus 2, and y equals negative 1/5 x minus 4. Anytime you have the exact same terms in both equations, you can subtract the equations to eliminate the variable. So we have y in both equations. Let's subtract the equations to eliminate y. Y minus y is 0, so it cancels out, it gets eliminated. And then you subtract each term. That negative applies to each term. Therefore, it's 1/5 x minus negative 1/5 x. The two negatives make a positive, so it's 1/5 x plus 1/5 x, which is 2/5 x. And then 2 minus negative 4, the two negatives make a positive, so it's 2 plus 4, which is 6, positive 6. Then subtract 6 from each side. 0 minus 6 is negative 6. And then equals 2/5 x. Multiply each side by the reciprocal, 5/2. The 5 on top cancels out with 5 on the bottom. 2 on top cancels out with 2 on the bottom when multiplying. We can cancel out 6 on top with 2 on the bottom by dividing each by 2 to get 1 and 3. 5 times negative 3 is negative 15. So x equals negative 15, just like we obtained before. And then to find y, substitute in negative 15 for x in either of the equations. I'm going to substitute it into the bottom equation this time to get y equals negative 1/5 times negative 15 minus 4. According to PEMDAS, we do m for multiplication before s for subtraction. Negative 1/5 times negative 15, and negative times a negative is positive. 15 on top cancels out with 5 on the bottom when multiplying, because each of those can be divided by 5 to get 1 and 3. Negative 1 times negative 3 is positive 3. 3 minus 4 is negative 1. So y equals negative 1. You can write the answer in coordinate form as negative 15, comma, the y number negative 1 if you want to. And now let's go to a word problem, example 6, and then we're done. A toy robot and its pet robot together weigh 204 kilograms. 4 times the weight of the pet robot is 4 kilograms less than the weight of the toy robot. How much does each robot weigh? So let's write that out. Example 6. A toy robot and its pet robot together weigh 204 kilograms. Four times the weight of the pet robot. Four times the weight of the pet robot is 4 kilograms less than the weight of the toy robot. How much does each robot weigh? So we need to solve for two variables: the weight of the toy robot T and the weight of the pet robot P. So we need at least two equations to solve for the two variables. we can make an equation out of the first sentence. A toy robot and its pet robot together weigh 204 kilograms. That's going to be T for the weight of the toy robot plus P for the weight of the pet robot equals 204 kilograms. Now let's make an equation out of the second sentence. 4 times the weight of the pet robot is 4 kilograms less than the weight of the toy robot. So 4 times the weight of the pet robot is 4P. And we have the weight of the toy robot T. It's saying in that second sentence that 4P is 4 less than T. So to make them equal, you either add 4 to the side that's 4 less than to make them equal, or you can subtract 4 kilograms from the side that is 4 kilograms more than the other side to make them equal. So either of these equations works. This equation's better because T is already isolated here. So we can substitute in 4P plus 4 for T in the other equation. T is already by itself on one side of the equal sign here. So we can substitute in 4P plus 4 for T in the other equation. Let's do that. So that's going to be 4P plus 4 plus P equals 204. Since it's just addition going on here, parentheses is not necessary when substituting in. And now combining the like terms, 4P plus P, or 4P plus 1P, same thing, is 5P. 5P plus 4 equals 204. Subtract 4 from each side. We get 5P equals 200. Divide each side by 5. 200 divided by 5 is 40. So P equals 40 kilograms. The pet robot has a weight of 40 kilograms. And to solve for T, we can substitute in 40 for P in any of the equations. This one, let's just substitute it into this one since T is already isolated in this equation. That's going to be 4 times 40 plus 4 equals T. According to PEMDAS, we do M for multiplication before A for addition. 4 times 40 is 160. 160 plus 4 is 164. And 164 kilograms is equal to the weight of the toy robot. And you can check your answer by doing 164 kilograms for the weight of the toy robot plus 40 kilograms for the weight of the pet robot, and you would see that together their weight does indeed equal 204 kilograms. And then checking it with the second sentence, 4 times the weight of the pet robot, so 4 times 40 kilograms is equal to 160 kilograms. And the weight of the toy robot is 164 kilograms. And 160 kilograms is 4 less than 164 kilograms, as it's talking about in the second sentence. So our values obtained for the weight of the toy robot and the weight of the pet robot is consistent with the information in the first 2 sentences of the word problem, so we know we have the correct answer. And that concludes section 611, Solve Systems of Equations by Substitution and Elimination. Thank you.